Welcome to the REDATS channel. My name is Hubert and today I'm going to show you how to correctly balance steel and aluminum wheels on the REDATS W-230 wheel balancer in the ALU1, ALU2 and ALU-S modes, and I'll also explain the differences between these programs. Before balancing a steel or aluminum wheel, we need to inspect it first. We begin by checking the mounting surface where the rim contacts the hub. It should be clean and free of corrosion. Besides the rim, we should also examine the tire to make sure there are no damages or bulges, and that no stones or foreign objects are stuck in the tread. After cleaning it, we check whether the wheel is properly inflated and we can mount it on the machine. Depending on the rim's design, we can mount the wheel in two different ways. The first method is mounting the wheel with the cone from the inside. We start by selecting the cone that matches the centering hole of the rim. Then we place it on the shaft and mount the wheel. Now an important detail. We need to put a spacer sleeve on the nut so the cone has space to retract when tightening the wheel. As you can see, the cone slightly protrudes on this side of the rim, and if we didn't use this sleeve, the nut would press against the cone while tightening and the wheel would not be centered correctly. That's why we take the nut with the spacer sleeve and tighten the wheel onto the machine, gently pushing the wheel toward the cone. Sometimes you need to hold the shaft with one hand and tighten the nut with the other. This is because there is a spring inside the shaft that pushes the cone into the rim's centering hole to make wheel mounting easier. The second method is mounting the wheel with the cone from the outside. Here we also start by selecting the proper cone, but we fit it from the outer side. When mounting the wheel on the balancer, we begin with the wheel, then the cone, and then the nut. We need to remove the spacer sleeve from the nut and replace it with the smaller sleeve. Now, while tightening the wheel, the nut presses the cone, which centers the rim on the shaft. It is important to slightly tilt the rim at the top so the wheel centers correctly. Here we have an example of a rim whose design requires using the cone from the outside because this area has a protruding casting for attaching the hubcap, which makes it impossible to use the larger spacer sleeve on this side. Since we already know how to mount the wheel, we can move on to balancing a steel wheel. We start by placing the wheel on the machine. We check the right column to see which program is currently active. If no indicator light is on, it means we are in the steel wheel balancing mode. We begin by removing the old weights from the wheel. Next, we enter the parameters. We extend the measuring arm and place its round tip under the rim flange. The machine automatically reads the distance of the wheel from the machine and its diameter. We take the caliper, place it under the left and right rim flange, and measure the width. In our case, the wheel is 6 inches wide. We enter this value using the B+ and B- buttons. To measure this wheel, we close the guard. The wheel has stopped, so we open the guard. The machine informs us that to balance this wheel, we will need 25 grams on the left side and 20 grams on the right side. We begin by locating the imbalance point. We slowly rotate the wheel until all indicators on the left or right side light up. We now have the left side set. We take a 25 grams weight and hammer it on exactly at the 12 o'clock position. We do the same on the other side. We rotate the wheel to locate the second imbalance point, take a 20 grams weight, and hammer it on at the 12 o'clock position as well. Then we close the guard to verify the result. The balancer displayed 0, 0, which means the wheel is properly balanced. We remove the steel wheel and can proceed to balancing aluminum wheels. The machine has 3 basic modes for balancing aluminum wheels. We press the ALU button. The first program is ALU1, and at this moment the indicator light for ALU1 appears on the display. We mount the wheel on the balancer and check whether there are any old weights on the rim. If there are, we must remove them and clean off the adhesive residue. After checking, we can proceed to entering the parameters. We extend the measuring arm and place its round tip against the rim flange, hold it for a moment, and then put it back. If we place it where the weight will be glued, the machine will incorrectly read the distance of the wheel from the machine and the diameter. I'll measure the wheel again so the machine reads the correct parameters. Now we take the caliper and place it on the rim, on the left side at the rim flange, and on the right side roughly at the tire bead height, and we read the width. In our case, the rim is 8 inches wide. We enter this value into the machine using the B+ and B- buttons. The parameters are entered, the ALU1 program is active, so we close the guard. The machine showed 25 grams on the left and 45 grams on the right side. We slowly rotate the wheel to find the imbalance point. We now have the left side. We take a 25 grams adhesive weight and stick it at the 12 o'clock position on the left side. Then we locate the imbalance point on the other side. Take a 45 grams weight and also stick it at the 12 o'clock position. We close the guard to check the result. The machine showed 0,0, meaning the wheel is balanced. We can move on to the next program by pressing the ALU button on the keyboard. On the right side display, the program has changed to ALU2. ALU2 differs from ALU1 in the way the left side of the wheel is balanced. In ALU1, we use an adhesive weight, while in ALU2, we use a clip-on weight. The method of entering parameters for ALU2 is the same as for ALU1. The measuring arm goes under the rim flange, and the width is measured with the caliper. We are working with the same wheel, so the width remains 8 inches. We check that there are no weights left on the rim, and close the guard. We have 20 grams on the left and 50 grams on the right. We slowly rotate the wheel to find the imbalance point. The left side is set. We take a 20 grams clip-on weight and clip it onto the rim at the 12 o'clock position. Then we rotate the wheel to find the imbalance point on the other side. Here we have 50 grams, so we take an adhesive weight and stick it on the inner side, also at the 12 o'clock position. We close the guard to verify the result. We have 0.0, the wheel is balanced. The last program for aluminum rims is the ALU-S mode. We can activate it by pressing the ALU button until the indicator next to ALU-S appears, or by extending the measuring arm to the 2 weight placement positions. In that case, the program activates automatically. We take the measuring arm and place it at the spot where we want to apply the first weight on the left side. We wait until dashes appear on the display. Without retracting the arm, we extend it deeper into the rim and place it at the second spot where we want to apply the weight, then hold it there. The display will show ALU-S. We then return the arm to the machine. In this mode, we do not use the caliper and we do not measure the wheel width, because the machine automatically reads the distance of the weights from the machine. The first display shows the distance of the left weight from the machine. The second display shows the distance of the right weight from the machine. The third display shows the diameter at which the left weight will be applied. Additionally, when we hold the fine button, a fourth measurement appears indicating the diameter at which the right weight will be applied. To summarize, in this program we input the coordinates of the weight positions on the rim, not the parameters of the entire wheel. Therefore, we do not change any of the values the machine has read. As an example, let's use the wheel we just measured. This is an 18-inch rim. Because of the rim thickness at the points where we place the arm, the weight will be applied at a smaller effective diameter. That's why the machine read 17 inches. I'll enter the parameters for this wheel once more. Arm to the first weight position, dashes appear, then to the second weight position, ALU-S appears, and then we put the arm back. The machine has read the parameters, so we close the guard. We have 25 grams on the left and 50 grams on the right. We rotate the wheel to find the imbalance point. We have the left side. We take an adhesive weight and apply it at the 12 o'clock position exactly where we placed the arm earlier. We rotate the wheel to the second imbalance point. We take another adhesive weight and apply it at the 12 o'clock position, again exactly where the arm was placed before. Once the weights are attached, we close the guard to check the result. The machine displayed 0.0, which means the wheel is balanced. The second method of applying weights in the ALU-S mode is applying them using the measuring arm. As before, we place the arm in the two weight placement positions, first on the left side, then on the right side. We make sure there are no weights on the rim and we close the guard. We have 25 grams on the left and 45 grams on the right. Now, if we want to apply the weights using the arm instead of placing them at the 12 o'clock position, we must press two buttons at the same time, Stop and ALU. Dashes will appear on the center display. Next, we rotate the wheel to find the imbalance point. We have the left side, which requires 25 grams. We take the weight, remove the protective tape, place the weight in the slot on the arm with the adhesive side facing upward, and extend the arm toward the wheel. The balancer will indicate how far we need to extend the arm so the weight is applied exactly where previously indicated. On the center display, on the left side in this case, because the imbalance is on the left, a small circle will appear. This means the weight must be applied at this position. We lift the arm upward to stick the weight onto the rim. Then we rotate the wheel to find the imbalance point on the other side. We prepare the next weight, in this case 45 grams, place it in the arm slot the same way, and extend the arm inside the wheel. Now, on the right side of the center display, a square appears. This means that the weight must be applied at this point. We lift the arm to apply the weight and then retract the arm. Once the weights are applied, we close the guard to check the result. The machine displayed 0-0, which means the wheel is balanced. The third and final method of balancing in the ALU-S mode is applying adhesive weights at the 6 o'clock position using the laser. Just like before, we place the measuring arm in the two weight placement positions, left side first, then right side. We make sure there are no weights on the rim and we close the guard. We have 30 grams on the left and 45 grams on the right. Now, if we want to apply the weights at the 6 o'clock position using the laser instead of at the 12 o'clock position, we must press two buttons simultaneously, Stop and F. The center display will show LS. We rotate the wheel to find the imbalance point. We have the left side. We take the weight, in this case 30 grams, and apply it to the rim in such a way that the laser touches the left edge of the weight and splits its mass exactly in half. We remove the tape from the adhesive side and apply the weight. We then rotate the wheel to the second imbalance point. We take another weight of 45 grams and apply it the same way as before. The laser must shine on the left side of the weight, dividing its mass in half. After applying the weights, we close the guard to check the result. We have 0-0. The wheel is balanced. I hope this video was helpful for you. You'll find more videos about tire service on our channel. Subscribe so you don't miss any new content. Thanks for watching and see you next time.